Hello and welcome to 4-1. Today we're going to be talking about divisibility. And our goal is that you're going to be able to use divisibility rules when we get to some problems. Now I guess I'd like you to just watch this video and take notes with the overarching viewpoint of, these are just tips and tricks. Do you have to do it this way? No. Is it going to be helpful for you? Yes. Okay, you don't have to write down all these divisibility rules. I have a little sheet that we can tape into our notebooks tomorrow. So don't worry about that. Just make sure you're listening and kind of understanding the purpose for our divisibility rules. All right, and first we have our vocabulary. So first we have to know, what is divisible? What does divisible mean? And it's just a number is divisible by another number if it is a quotient, if its quotient is a whole number with no remainder. So for example, you could say 14 is divisible by 14, 7, 2, and 1. Right? Because if I do 14 divided by 14, my answer is 1. Whole number. If I do 14 divided by 7, the answer is 2. 2 is a whole number. Okay, so the thing that could I do 14 divided by 3? No, I'd get 3 and, whatever for a decimal. Okay, so we can't do 3. 3 does not go into 14 evenly. So then the same for another example is 12 is divisible by 12, 6, 4, 3, 2. You can multiply these numbers together to make 12. Okay, another thing we're going to kind of look at a little bit is what is prime versus what is composite. So prime numbers is a number that can only be divisible by 1 and itself. So an example, this would be 11 is a prime number because the only way to get to it is to multiply 1 by 11. You can't do 2, can't do 3, can't do 4. We can't do any of those other numbers. We can only do 1 and 11. Whereas composite here is numbers that are divisible by 2 or more numbers. They are composite numbers. Okay, because it's divisible, 6 is composite, it's divisible by 1, 2, 3, and 6. So really, if it was only 1 and 6, it would be prime, but because it's got the 2 and 3, 2 times 3 equals 6, it is composite. Alright, so here we have our divisibility rules from the book. I liked this one because it gives an example of divisible and not divisible. So bear with me here. A number is divisible by 2 if the last digit is even, 0, 2, 4, 6, or 8. So if the last number is 0, 2, 6, or 8, it's going to be divisible by 2. If it is not, then it's not going to be divisible, right? 5 is not 0, 2, 6, 2, 4, 6, or 8. So if it's divisible by 3, if the sum of the digits is divisible by 3. So if I add 3 plus 1 plus 5, I would get 9. And 3 goes evenly into 9. So I could say, yes, the number 315 is divisible by 3. If I add up 1, 3, and 9, 1 plus 3 plus 9, I would get 13. And does 3 go into 13 evenly? No, it doesn't. It would go into 12, it would go into 15. Does not go into 13, so this one is not divisible. Alright, 4. If the last two digits of a number form a number divisible by 4. So if I look at the last two digits, and that's something for 8, 12, 16, 20, 24, 28, 32. If it's one of those numbers, it's going to be divisible by 4. Here I've got an 18. That's not divisible by 4, so it's not going to be divisible. The whole thing's not going to be divisible by 4. It's going to be divisible by 5 if the last digit is 0 or 5. Here we've got a 5, here we've got an 8. Not divisible. Okay, 6. If the number is divisible by both 2 and 3. So this one we don't have to calculate anything. We can know, was it divisible by 2? Was it divisible by 3? We can just know if it's divisible by both those two, it's going to be divisible by 6. Now this seems like a lot of information overload. Like I said, this is just tips and tricks to use, and we'll kind of go through it. But I just wanted to read through this with you, talk it through a little bit, okay? So 48 is divisible by 2. Yep, because it follows. The last digit is even. And 3, the sum of the digits is divisible by 3. 4 plus 8 is 12. So that would be divisible by 3. So yes, divisible by 2. Yes, divisible by 3. So yes, divisible by 6. If the sum of the digits is going to be divisible by 9, if the sum of the digits is divisible by 9, so again, if I add 7 plus 1 plus 1, I would equal 9. Okay, so is 9 divisible by 9? Yep. Is 9 plus 3 divisible by 9? Nope, 12 is not divisible by 9. If I count by 9s, I don't hit 12. All right, and lastly, it's going to be divisible by 10 if the last digit is 0. Not. Okay, so anyways, let's follow these rules to see if 610 is divisible by 2, 3, 4, and 5. So again, I have this chart for you printed out, so I'll hand that to you. We'll tape it into our notebooks tomorrow. Okay, so let's start off with 2. So let's go up and read number 2. If the last digit is even, is 0, 0, 2, 6, 4, 6, or 8? Yes. So is it divisible by 2? Yes. So I'm just going to kind of put my numbers that it is divisible by in a line. So is it divisible by 3? So I'm going to go up and read. If the sum of the digits is divisible by 3. So if I add 6 plus 1 plus 0, I would get 7. Is 7 divisible by 3? Nope. Okay, so we know it's not divisible by 3. So now I'm asking if it's divisible by 4. Let's go up. If the last 2 digits form a number divisible by 4. So I have the number 610. I'm going to look at the last 2 digits, which is 10. I'm going to say, is that divisible by 4? Well, 4, 8, 12. Nope. Not divisible by 4 because I skip over 10. Okay, and lastly, they're asking about 5. It's divisible by 5 if the last digit, the 0 here, is a 0 or a 5. So, yep, it is divisible by 5. So the number 610 is not divisible by 3 or 4, but it is divisible by 2 and 5. All right, let's try some more. All right, so now we're looking at the number 387. We want to know, is it divisible by 6, 9, and 10? Okay, so if I'm reading this here, I've got to look at 6 is kind of tricky because you have to know, is it divisible by both 2 and 3? Okay, so let's look at 2 and 3. Is the last digit 0, 2, 4, 6, or 8? No. So, because it's not divisible by 2, it's also not going to be divisible by 3 and not divisible by, well, it's not going to be divisible by 6. So I can say no to 6. Is it divisible by 9? If the sum of the digits is divisible by 9, so sum means add. 3 plus 8 plus 7. Alright, so I can make a 10. 3 and 7 makes a 10 plus an 8 would be 18. Is 18 divisible by 9? If I count by 9s, do I hit 18? Yes, I do. So yes, it is divisible by 9. Is it divisible by 10? If the last digit is 0, is the last digit 0? No. So this number, 387, of the numbers they gave us, it's only divisible by 9. Alright, so now we're trying to answer the question, is the number prime or composite? Okay, so if the only number that this is divisible by is 1 and itself, then yes, prime. If it's divisible by other numbers, then we would say it's composite. So I already know the 5, it ends in a 5, so it's going to be 5 times something. So I know that this one's going to be composite. And this is where our divisibility rules really help us out. So I know if it ends in a 0, it's divisible by 10. It's going to be composite. If it ends in a 5, it's divisible, or a 0, it's divisible by 5. So it's going to be composite. If it ends in an even number, composite. Okay, so now things get a little trickier because we don't have any more even numbers. We don't have any more 5s or 0s. Let's go to 13 next. Okay, 13, I mean, if I'm going through my head quick, is it divisible by 2? No. Is it divisible by 3? No. 4? No. 5? No. 6? If I count by 6s, 6, 12? Nope. If I count by 7, 7, 14, I'm already over. So this is a prime number because it's only divisible by 1 times 13. That's it. Only way to get there. All right, 19. Okay. Is it divisible by 2? No. 4, 3, 4. If I go through all of them, I know it's just, this is going to be a prime number. Because the only way to get there is 1 times 19. Okay, now lastly, if I look at 49, now this one looks like it's going to be prime, but here's what I know. I know that 7 times 7 is 49. That's a double. And so I can say that I know this is a composite number. Okay? So that's, you guys, where knowing those multiplication facts really comes in huge, because you can look at a number like 49 and not have to say, okay, is it 2? Is it 3? Is it 4? And you'd have to go all the way up to 7. You'd have a lot more thinking. So if you just know those multiplication facts, you can know, oh, I know 49 7 times 7. So it's not prime. Okay, so that's why it's so important to know those multiplication facts. This lesson is going to be very valuable in the future, so I think if we get a lot of extra practice using these divisibility rules, it will help you out. Anyways, we'll see you tomorrow. Thank you for watching.